Hello, everyone, and welcome to session number 8, I think. Isn't it, Raymond?
I think so.
And how are you dealing with all this? Getting bored?
No, it's getting more exciting every single time.
Well, that's very kind of you to say. Um, so, where did we leave off last time?
So last time we added um determine a group of two, surrounding a group of two in a vertical position.
Oh yeah,
So
someone
and
said in the
then we added
comments that we're actually digging ourselves into a hole there. So that might be interesting to see how we end up with what kind of algorithm.
yeah, yeah. Um well I was thinking that we might end up refactoring in the end. So
Well, we can start refactoring now if you want, or we can add some more features. Let's see what do we have so far. Do we like the code that we have? Let's see.
um
Yeah, not crazy about it. Remove story surrounded is kind of looking weird now.
right, with the fully surrounded and almost surrounded parts.
Yeah, so we have a like a surrounded on top, on to the right. That's interesting. Um,
So
so
this stuff,
yeah.
this code is only for like two stones connected together. Like what happens when we add a third stone? So should
Sure.
we? That would definitely like change things a lot. So should we refactor before we start adding tests for a group of three, or should we add that and then that would be taken into consideration in the refactoring?
It's our choice. Usually, I would say let's refactor first because the code is already kind of ugly.
Uh,
Also, we have two choices. I mean, just about that feature, we can either choose to implement almost around it to the left or to the bottom,
mm,
um, or go to surrounded by three or more. I mean, three or more being surrounded.
mm-hmm.
So, and based on our choice, our design is going to change as well.
Right.
So, what do you think? What do you want to do first?
I think normally if I was to do this on my own, I probably want to consider refactoring, at least in the position where our code is right now. I feel it's really hard to, I feel it'll be a lot of work to add in another test for surrounding a group of three with the code we have right now.
Sure.
So,
Okay. So, how do you want to refactor this? Do you have any interesting ideas?
um, so I just find it interesting in the first place that we have and is fully surrounded by and almost fully surrounded by.
Okay.
Um,
And they're kind of
so
repeating
one of,
themselves.
right.
Okay. So,
So the thing is, like, you know how like I implemented this before, right? So the way I did it, though, I'm worried that sometimes that the way I did it before might affect like the test that we write, or like maybe just I might end up just jumping into it and skipping the whole TDD process. Because the way I implemented it was that I would get all the stones and then get and all the stones that are connected, and then get the um, positions that are adjacent to the stones and check that they're all filled with white.
okay, I don't understand how is that happening in terms of design, though.
I mean, like right now, I'm worried that it doesn't. I mean, it's totally different from what the way we're doing it right now, and um, I'm worried that it's not like driven by tests.
Hmm. Okay. So,
So is that a problem?
well, I'm trying to understand. Is it a problem on your own different implementation? Is that what you're asking?
Yeah, like switching from one implementation here to another implementation.
Well, it wouldn't be a big problem, but my guess is that the possible risk here is that there would be some features that aren't being tested that already exist there. So it would be more generic than this code, and so
Right,
we would have less of an inclination to write any tests for it.
right. I see.
Okay?
Okay.
I mean, we could switch it all, and then these things will actually work, but then we won't know which features actually exist. We will have to like guess which test we want to write. And in real life, usually, if you do it like that, you just say, okay, well, it actually works really nice. I can't think of a failing test for this, and that's it.
Hmm.
And the whole point here is that you're not objective. We are not objective when we write the code.
Hmm.
So by writing it as simply as possible, we're forcing ourselves to also think about the tests.
Okay.
So if we implement everything, we're not forcing ourselves to think about the tests, and we're basically saying, yeah, well, tests are not as important for this. It doesn't have to be covered in terms of functionality. It just has to have some tests. And
Right.
I want every character, every line in the code to have a reason to live, basically.
Okay.
Now, in terms of possible refactorings, there are two kinds of rules that I always look to. And one is don't repeat yourself,
Hmm.
and the other is the single responsibility principle.
Right.
Okay, so that
Right.
every method has one reason to change, not two, not three.
Right.
Um, so in terms of refactoring, I think there's plenty that we can do here.
Right.
I mean, if I look at the code, um, remove stone is surrounded. I mean, this thing here, I mean, if you look at this, this is actually setting two stones. It's actually setting stones to empty, right?
Right.
So, and this the same here.
Hmm.
So what if just as a start measure, I will refactor and say uh, remove stone with XY.
Okay. Okay.
Um, it's the same here. It's almost the same here.
Right. But x plus one.
Cool. And here it's XY and XY minus one.
Right.
Cool. Um, Now, when I do that, I see that I have removed stone. I don't have to repeat this three times.
Right.
That makes sense?
Uh-huh.
I mean, it almost looks like uh, I have to remove it if it's fully surrounded. I have to
Right, I
remove
see.
it. I mean,
So
is
you
there
want to
any
make
case where
one
I don't have
conditional
to remove it?
statement for
Sorry?
that?
What?
I was just wondering how you're gonna make it not repeated.
Well, I don't have a magic formula. I'm just thinking out loud about how I might do that.
Okay.
But basically, I don't want to. If I'm repeating myself here, maybe there's a way I don't have to do it.
Hmm.
Maybe there's a way I always remove the current stone, and I possibly also remove a stone next to it.
Right. What would you like say about um, if you move this line out and then you put like a copy of these? I mean, it would be another duplication, but it'd be a duplication inside the conditional.
So you would send them as delegates.
I I don't really follow. We mean send it as delegates.
So you would send them as a Boolean parameter or as or is action delegates to be invoked at the method?
I meant like copying this
Yep.
into
Like a remove stone
if or, but that would be like duplicating the conditional.
Oh, I thought you meant call remove stone with the conditional.
What do you mean by call stone with the conditional?
Um, Remove stone, this.
Oh, I see.
Like a remove stone if.
Hmm.
Like if fully surrounded. Let's see. So let's think about this logic for a second, okay? Remove stone is surrounded. We remove it if it's fully surrounded.
Hmm.
Remove it. Oh, so that's interesting. So the way I think about it now is that we do have an interesting refactoring we can do here. So remember when we had strategies that didn't make sense for detecting
Right.
that something should be for detecting a winner?
Mm-hmm.
Because there's only one way to detect a winner, I guess. But
Yeah,
here we might have strategies to remove stones.
I
So this
see.
first one is remove a fully surrounded strategy. Second one
Okay.
is surrounded on right strategy. And this one
Okay.
is surrounded on top strategy, like a
Okay.
removal, like a chain removal strategy or something like that. And that way we don't have to have the if. We would basically have like either a base class or something like that that basically does the checking and has like a strategy for detecting all the different things.
Okay. Okay.
Does that make sense?
It makes sense.
Um,
But the thing is that if this is a separate strategy and this is a separate strategy,
yeah.
the almost surrounded is going to be calculated twice. Is that going to be fine?
Well, we don't care about performance yet.
Okay.
Remember, it has to work, and then we can optimize.
So we want to reduce duplication in code first, and then duplication in like performance wise is secondary for now.
Yeah, later we can optimize the hell out of it, but it has to
Mhm.
work. I mean,
I
it
see.
has to be maintainable. And when that works, we should hopefully have only one place to change it, maybe somewhere in the
Okay.
base class or something like that. Because you won't have to have that duplication. You might have the checking the almost surrounded in the base class or somewhere.
Okay.
So here's an example. We can start the refactoring by saying stone remover, remover equals new stone remover. Okay,
Okay.
X and Y, and he takes in the rules and the board. Actually, that already is too many parameters. So I would actually call it directly with a parameter object, like new removal arguments that has these properties. So we would have like x equals x, y equals y. What else do we have? We have um, um, the rules, right? Rules equals rules, and board equals board.
Um, it's inside
This,
the board class. So this,
yeah.
yeah.
Um, so that so new removal of the thing
You have a extra
like this, right?
parentheses like right here.
Did I miss anything?
I don't think so. I think you got it. Oh, you're missing a comma right here.
Okay, put it. Cool.
Done.
So if we had the stone remover class, first thing is we would put all this into that stone remover class. Okay?
Mhm.
And then it would refactor to different strategies.
Okay.
Otherwise, the board knows too much already. So we
Right.
can go ahead and say create a stone remover. Create the class here of this removal arcs. And just basically go ahead and create all these properties. Right, public int x, public int y. Moves. And
Board. Yeah.
something is more accessible than the other. Let's see.
Maybe rules class is not public.
Sure. Cool. So now, let's see where we're. So now basically I would go and say remover dot remove. Horrible.
What are you typing on?
Probably something that's not a keyboard title. Remover. It's like if Schwarzenegger was typing.
Yeah.
And then we would have all this. And our first thing is to get rid of all that logic. Can you refactor and put that all that there? I think that it'll be faster.
So take all this
Yeah, and put it in the remove method, which doesn't exist yet.
and put it in stone remover.
Yeah, in the remove method, which we have to generate.
But what would be the best way to generate it? Is it like this?
Yeah, exactly. Tab, tab. What the hell? Nope, that's not what we meant. Now we will. Okay, now if you okay, try to paste it, see what happens. Yeah, and we also need to remove stone. Forgot about that.
Say again.
It's still in the board.
Oh, it's still in the board. I see. So I gotta move this out.
Yeah, just import it.
Alt enter.
Yeah, but the remove stone method is still on board. That's why it's saying that it doesn't
What do you mean
recognize it. There's a method
Oh,
called remove stone. It's just like here you passed it.
you're talking about this?
Yeah.
You're talking about this method, the remove
Yeah.
stone?
It's still on the board class.
Yeah. So you don't want it inside the board class? You want to take it out?
Yeah, because it's or we can
Okay.
make it public. We would say board.remove.
I see. Nick, I don't think there's anything wrong with board dot remove.
except that we have a class that the whole point of it is to, oh, because it needs access to the stone matrix, right?
Right.
Public. Cool. And so we
Wait,
just have to
so
replace it
what
with
was your
board
issue with
objects.
having a remove stone in the board that you had? Oh, that has to access another class.
Yeah, I mean, it's a stone remover, but that's okay. I forgot that it needs access to the board matrix.
Right. You're mistyping everywhere,
Of
by the way.
course.
So this is saying you treating it as a static. I mean, we had to create a property for board right now.
We should already have one. Oh, it's args.board actually, right? So we have to
See.
save it. Or we can, if it's, it can't be static, right?
Right.
Yeah, so we just have to have a
So
property called board that we can, or args.property called board,
right.
like introduce initialize args. And
Nice.
then we can say, you know, args board.
Okay. I can type it for you.
Okay.
Okay.
Yeah, but remove takes an X and Y. No?
I see.
No, it doesn't.
Yeah. I thought I thought it so it didn't. Oh, so no, you define x and y in the remover. Okay. So you're talking about args.xy.
But you know what we could do is just to make things much easier. Instead of just replacing args XY everywhere,
Right.
is we can do,
Well, what just happened?
I
How
don't know.
come there's ghosting?
Okay, but what if we just did like this? Yeah, I can definitely see the ghosting here. If we took the whole method, jeez. What's with this ghosting thing? Team viewer.
Maybe it's better if I well actually I won't do it right now.
There we go.
Okay, it's
So
cool.
what if we just did this? Move int x in y. Then we'll just say remove args x args y.
Okay. But what about the rules object? Do you want to define that as a parameter too?
Well, we can use args.rules. It's easier.
Okay.
We can make this non-public if we really wanted to. So we'd say args.
Okay.
I've gone ahead and copied this for you so you can do your thing.
All right.
Okay, we're back to green. That's good. So we're doing it slowly but surely. So now at least the board and the remover are in different places.
Mm-hmm.
So the removal logic, which is getting quite out of hand, is at least we can at least it's clearer. So if we look at the board back here, stone added, check around and remove if needed. That's the rules, right?
Right.
That's interesting. The board has rules. The rules call check. And the rules call then later to the board itself, remove stone if surrounded. And the
Yeah.
rule, and then the board calls stone remover. So we can
Yeah.
make that nicer as well. We can go ahead and just maybe the logic that goes through each one be different. I'm not sure. I mean, there is kind of like a weird path. See what I mean?
Yeah. Can you go back to why does the rules why does the board calls rules again?
Well, we used to have we have a method called check stone around position and remove,
Mm-hmm. Mm-hmm.
which does this. So this is the only reason, because we wanted to have an algorithm that just looks around
Mm-hmm.
the thing that was just added.
Right. Right.
Instead of calling board, the rules can actually create a new remover for each one and be done with it.
That
But that's
yeah.
what the board does anyway, right?
Right. Well, wait. What does remove stone is surrounded do now?
Go
It's
go to it and you'll see.
where is it? Um.
I mean, we can just extract this method and put it
Right.
into
You're
rules
right.
and be done with
You're
it.
right. You're right because it doesn't do anything straight from the board. You're right.
We'll go ahead and say, um, let's say this. Then we could just use Alt here. Yay!
Nice. Much cleaner. That's quite amazing how that worked out. So, because we extracted it into another method.
So
Pretty
it's
nice.
we still have some work to do, but the point is that now the board has a single responsibility, and that is simply to manage the stones, nothing
Right.
else. It has the rules, and the rules decide what to do when a stone is added. And it has a remover. I can has a remover that removes things.
Mm-hmm.
So now we can make removal strategies here, maybe.
Right.
So, and again, slowly but surely will work. So basically, we can say, like, we can do all this right now as a method and say remove by fully surrounded strategy. And then we would have this remove by right chain. What would we call it? Just
Um,
how would we call it?
remove if almost surrounded, except to the right. That's pretty long.
Remove to the right. Maybe.
Uh,
Oh, it's
I
experiencing almost surrounded? That's interesting. Did I miss something? Did I?
I think it might have been when you selected the whole
Oh,
thing and
yeah,
you
we
thought
don't
you were
need to
trying to
almost.
return um, a parameter or something like that. So if you try Control M or Alt R and R enter, was it Alt enter?
What are you trying to do?
How come it's not refactoring?
Control Alt M to refactor.
Oh, Alt F. What the heck is going on?
Control Alt M.
Oh, Control F. Okay. I think it's because it selected a return value right here. So you wanted void, right?
No, the problem is that we have an if here that uses something.
Oh,
So
it
it has to
uses the
return that
same
value.
almost surrounded, right?
Yeah. So if we did that instead, we would say surround on top 2.
Right.
I can make this strategy separate.
Okay, I see.
Wait.
Let's call it removed if chain on right surrounded, or if
Well, it's still going to return something. No.
no, it says
Oh, it's
return
fine.
void.
Okay.
Yeah.
Removes. What would you put in the name?
All right.
Okay. And I like how we're getting the feedback without running the test that we didn't break anything.
Yeah, it's very nice. Cool.
And now we can go ahead and for each one create like a strategy for it. And then later we can even remove the calls to the methods. So you would, another thing we can do is just keep it this way.
Mm-hmm. Okay.
So what do you think?
I don't understand the other way though. I understand keeping this way. I don't understand um, creating a class and um, the other way you mentioned.
Okay, so it's almost as if we did the get winner strategy,
Mm-hmm.
but as a removal. So we would say fully surrounded strategy. Okay, so we would have like um, removal strategy. What if instead of strategy we would have like a detector that tells you what to remove instead of removing it, right? Because we have a class that removes things. So
Right.
it would be like um, removable detector or something. So
Sure.
removable
Let's go with that.
detector. Um, surrounded. Fully surrounded detector equals new. Fully surrounded removable detector. Okay. Now the way it would work is that we would say fully surrounded removable detector detect for the board. It would have like an args. Okay.
Okay.
And what it would return is like what we need is basically an array of XY positions to remove.
Okay. All right.
So how would you declare that?
And
It's an
so
array
array.
of pairs, basically an
Um.
array of pairs.
Um.
Or
Well,
it can
I
be a
was gonna
list
do.
of,
I don't know another way
okay,
except this one.
no problem. results. Okay, it doesn't make, oh, Alt Enter to add the list. And Alt Enter again, cool. And then basically,
Is this one supposed to be? Is this one supposed to be this
yes,
value?
yeah.
Okay.
And then we would basically do like results each.
It just be the same line as this thing.
Art
Yeah.
for dot remove stone as tuple item 1 and tuple item 2. That's what we're gonna get.
Yeah.
Yeah. So that's basically what I'm thinking.
Okay.
And that basically each one of those detectors might return multiple things. We don't care.
So is that thinking too far ahead?
Well, we're already trying to make it a bit more general in that is it too far ahead? Do you think it just should return a tuple and that's it? Sure, we can make it just a tuple.
Just for now, and
Sure,
then
sure. I like the way you think. We don't have to do it. We don't have to do it.
I'm just saying, like, I'm just wondering. We need to do a check if the
Just
tuple's null.
results. Sorry?
We didn't need to do a check if the tuple is null. Like, if the
No,
tech.
now you're thinking ahead.
Now I'm thinking too far ahead. Alright.
Okay, so basically we're gonna have this in the removal detector. Can you make that?
Yes.
Yeah.
Oh.
Yeah,
Sorry?
sure.
Okay.
No problem. We can move it later.
Okay.
Actually, yeah. We have to call it a fully surrounded removable detector
Well,
that inherits
that
from
one.
a removable detector.
Right. So just I'll enter this one, right?
Sure. And then we have a detect, which is like an abstract method. Cool.
And this one overrides.
It's abstract. This method has to be abstract.
Okay. Do I need
It has to
what
be
is that?
public too.
Public abstract?
Yeah, now just remove the body.
Isn't that alright?
And I think it has to be an abstract class as well. Sorry.
Okay.
And now this class has to implement it as well.
Oh, it's not override? It's just.
Well, you're working too hard. You see that red line there? Just press Alt Enter.
Alt enter?
Yep, it's always Alt Enter.
Alright. Implement members. Cool. Okay. It's
It's basically the same logic in a different place.
right. Except instead of removing, it should be
Just returning. Just return the tuple of x and y, right?
Oops. Yeah, if oh,
It's args.x,
sweet.
args.y.
Oh, what happened?
Where the hell did opposite color come from?
Though it was passed in the args. Should we put in the opposite color inside here?
Sorry?
Do we add opposite color to detect as a parameter?
Interesting question. Where is the opposite color coming from?
It's coming from before we had it right here, and it was from remove fully surrounded strategy, and that is from right here in the remove.
I think it's just board.get opposite color, or is it rules? You can just get it from rules.
Okay. Okay. I just want to do int x equals. So the problem is it doesn't have. It's not knowable.
Everything's
Okay.
broken.
So I'm guessing.
Hold on, let's make sure. Okay, so now we know at least that it's all in the new code.
Well, I think if we look at the error code, it's going to say
And
you
this code
can't
never,
call.
actually you'll see this code never gets executed. It's
Right.
black. So
Right. No reference. Right. So if I add in a line right here.
Oh yeah, we just have to check, yeah.
Oops.
Yeah, if you added a line right where?
Well, I was going to do that. If tuple not null.
Yeah, I think you can do it with, hold on. Well, yeah, that fixes it, but I'm just saying, I think you can do, like this. If you go on tuple, you should be able to say, check if it's not null.
Very cool. Okay.
Okay, now we can remove this.
Okay.
Okay, so now we have a class that knows how to detect like a single stone. Okay.
Okay.
Okay, so basically the process would be to go ahead and create, and each one of them will be a strategy. The one that looks to the right, the one that looks to the left.
Mm-hmm.
Now, what's cool about this is that then we can later do one that looks to multiple places, and it won't hurt all the others. Because they'll just return a list that doesn't contain X and Y if we already removed them.
Right.
What do you
Right.
think? Actually, that might be a problem, because if we already removed something that's fully contained,
Well, right now we're only using. Well, actually, the code doesn't prevent it from using multiple strategies.
yeah,
Right
so
now,
Yeah, but I think when we get to 3, we're gonna get there, and then we'll say the first one that works is the one we're gonna use.
Mm-hmm. Okay.
Otherwise, they might collide with each other at some point.
Mm-hmm.
Okay. So you want to do the other ones as well, or do you think that the strategy of 1 to each position is one strategy?
Strategy 1 to each
I
position.
mean, 1 to the right, 1 to the top.
Oh, that's a good point. I think that is one strategy. That the I well, is that generalizing it too much? No, I don't think it's generalizing it too much.
Well, we can try it. We can always refactor it later.
Okay, let's try it. You mean like try putting it as one strategy, right?
Oh, by the way, have you noticed we don't need these arguments anymore?
Right.
Look at this. We can say, we actually don't have to. And we'll say, just remove that. Okay, sorry. So now, what I'm thinking is that let's see, is that all these 3 are just a single strategy, but it's possible that each one of them is a different one. So it's a single strategy that's only partially working. I mean, yeah, not all 3. I'm sorry, just the bottom 2.
Right. All right. Okay.
But each one of them can be in its own strategy as well. So whatever you think makes sense.
Oh, I would like to do the single strategy, or a different version of a single strategy.
Okay, you want to try and do it?
All right. So you're saying. So the first thing I would need to do is change one of these to look like this, right? Uh, I'll just call it detector. New chain
Sure.
with neighbor. No, chain.
Well, by chain makes sense to me.
Okay, by chain. Surrounded strategy. Oh, it's detector. Surrounded detector. Sounds like your laptop's out of batteries.
How is that possible? Oh
Sounds like a ThinkPad.
yeah. Solves. Well, remember this one does not return a single one. It returns a list.
Right. Okay. Well, right now the way we have it. Oh yeah, you're right. It returns two. You're right. You're right. I see. I see where you're going. I see where you're going with that. Okay. You're clever. So because of that, I have to. Now, how would I do that change then?
Just do the change as if everything's great, and then make it compile.
Because like, well, I guess it would make another. detect. Because then, right now this detect is only returning a tuple, well, like one, it's not returning a list.
Yeah.
Okay.
But I think it will just force us to make the abstract return a list, but the previous one will just have one on the list, and that's it.
Right. Results dot. I like your for each use of list link.
Okay, now you can do Control Shift Enter. Control
Control.
Shift Space, sorry.
Okay. Is it this one? I see. Okay. And then, how do you do it?
Yep.
Okay. So what does this say? Change results. Place. Change type of results.
No. You have to change it to the abstract method level.
I was wondering if ReSharper was able to do that for me. That's what.
Maybe it did. Maybe I missed it.
No, it didn't look like it. It did. So. This one though. Well, this one. This one.
Just use the. Hold on. Instead, what you could have done is just tuple equals detect dot first.
Ah.
Wait, there's probably a link missing. If you go to
Yeah, system.link. I think it's a parentheses. There you go.
okay.
Okay.
So
And
let's
then,
make the other one work. New list, right?
right.
God damn it, Windows.
Okay, cool. Oh, something's still failing to build. Oh, it's because I don't have this one yet.
That might be important.
Say again?
Yeah, that one might be important.
Uh,
Was my attempt at a joke.
uh, um, so basically, maybe this copying this.
Yep.
What just happened?
Tab. Tab happened. You want to do the X and Y like you did before?
I did this, and I guess I could do. Actually, right. Yeah, I'll enter local variable. Then. And then
Still not compiling.
well, it's this part because I didn't return a list yet.
Oh.
So
Well, you know you have exactly 2 right now, right?
Right.
Then you don't have to like declare. You just create a new list with the 2 in there, right? Inside the
Okay.
if.
So you're talking about returning right here.
Exactly.
New, right?
Mm-hmm.
Okay. Oh, how come it's like that? Okay. Is that right?
No, it's a new list with an array, remember? It's an array of new tuples. Hold on.
Oh, okay. I know what you're talking about. Right.
Okay, then do it. With
You're talking about this, right?
no. Yes. 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 Yep.
Okay. And then
Just return null.
let's go
Nope.
ahead and pop
That
one.
didn't work. I guess you have to
Well, I
return an
think
empty list.
it's to checking if it's null first. This one is null exception. Value cannot be null. So this one's still checking if it's null. Um,
Oh yeah. True.
because you're calling first.
Oh yeah, I agree. So we
So
can't return null in the strategy. We just have to declare it nicely. Just return an empty list,
okay.
right?
Oh, oops, sorry. You wanna do it?
No, you do it. I think it would be faster.
Okay. Like that. All right.
Yep.
And then this one too. What? Something's still not wrong. Still, what's this? What's the wrong one running? Oh, okay.
I guess
This one
first
running
can't work.
contains no elements.
Oh crap. Yeah, so we have to do it the stupid way. Get the list, see if the list is empty, blah blah blah. God damn it. Can't C# just help me out? But the list does not have any items, sir. I don't know what to do. Is
Well,
there
we can
like a
just
first or default,
yeah.
which is better?
Um.
Oh, that's
Oh,
better.
okay. That works. Cool.
Okay, and in that case, we can go ahead and just...
Do we want to copy these 2 lines to here? Now that's working.
I don't understand. What do these? Where do they come from?
From the remove chain on right.
We have remove chain on right.
Right,
And the
because right now
results
it's
for each.
returning. We're doing the first or default.
Sure. It doesn't work. It's not the same.
I mean, if I
But you know what we can do is we can just have like a method that goes through a list of tuples and that's it. Right? Like here.
isn't that what it did?
No, what I'm saying is that this would be like a remove all items in
Okay.
list. Remove all list of lists.
I think you deleted the line that you just entered.
Hmm?
You just deleted the line that you entered.
That's stupid.
All right. So I just moved that. Now, how to make it more generic?
What do you mean more generic?
Well, look, we were trying to combine this one with this one, right? To use one detector.
Well, we don't have to have the second method call. That's the point. If we remove the second method call, then the first one should just work if we add that functionality to the thing.
Could you, I don't think I understand my second method call.
So we
Um,
have this one, right? Do you
uh,
agree? So now, if we didn't call this one at all, but we just
uh,
took the logic here and put it in the same strategy and make it return more results or different results,
I see.
then it would
Okay.
work. And then we can refactor the current strategy to make it more generic.
Okay.
So we remove something, then we check, and so it's small steps.
I see. So what should I do, right? So we should move that into the chain removal detector.
Well, first of all, I would remove the call to the method you're in right now, so it would force me to put the logic that it has inside the strategy of the chain. I would just, right on the method right here, I would say, let's not do that anymore,
Okay.
right? So this method becomes gray. I would say,
Yeah.
okay, if I didn't call it anymore and I wanted it to be in the strategy, in the removal, I would just go here and find a nice place to add that logic.
I see.
And when
Which
they
would
both
basically.
work together, I would refactor again to make it more generic.
Oh, okay.
So I
Okay.
already copied it. Where do you want to add this?
Um, it would be the same right here. So the difference would be, um,
Okay, that's good.
I mean, this would be, this one would be back to one.
Mm-hmm.
Arts.
Okay, that's good. So now everything's passing again.
Mm-hmm.
So we can remove the call to the other method, right? We just put it in a comment where we can remove that method altogether.
Right. So get rid of this, Control L, and then get rid of this.
Yeah. Now we can
Um,
go to the strategy and refactor it again.
right.
So now it's possible that the strategy has multiple ifs because it is a strategy that looks for different places. But we can make those
Mm-hmm.
ifs a bit more generic. Like, for example, given an x and a y, okay? Like if we had a list of sorry,
Mm-hmm.
tuple of int and int.
Um,
Yeah, of course.
I'll fix it for you. Sorry. Oh,
Do not dare.
all right.
To check equals get checkpoints for x and y. Now the checkpoints right now, we only have two.
All right.
Oh, that's not what I meant. Int, like this. Ah,
Oh,
collaboration
yes.
through committee. So instead of surrounded on right, here we're checking the x plus 1, right?
Mm-hmm.
And here we're checking the y minus 1.
Right.
Agreed? So imagine that we had a loop that takes like a list of checkpoints.
Right.
That given x, we would get x plus 1, y minus 1, like a tuple of this, a tuple of this.
Mm-hmm.
And right now it would just be these two tuples so that we don't add new behavior.
Right.
But then it would just work as a simple loop for each one of those. So surrounded and surrounded on that tuple. See what I mean?
Okay. Right.
Do you see what I'm
Okay.
getting at?
I see what you're getting at.
So
It definitely looks a lot cleaner now.
Okay, so if you do, so you want to try and get, implement get checkpoints for x and y,
Yeah.
and just return the hard-coded values or something. No, array. Yeah, you forgot the notation there.
Yeah. Oops, not really to do that, but x
So we have x
plus
plus 1 and y.
u
X and
x
y minus 1.
y minus 1. Oops, how did that happen?
And
Okay.
just to make it a bit more clean, do it like this. Sorry, that's what I meant. Now we have the list. Now let's turn this into a loop. I mean, basically, we have the opposite color, right? Oh, crap. So basically what we're trying to do is to turn this into something of a loop right here, right? For each, or
Right.
actually like to check dot for each. You want to try and do that?
Right.
Just
For
the
each
control shift space.
control.
No? Yeah.
Right.
So for each tuple, we're doing basically the same check, right?
Right.
Actually, here's something that will be, I think this will be more readable. We make it a delegate,
Okay.
so it looks more like a method.
Okay. Oh, what just happened?
Sorry,
Okay.
you do it. I'm not going to touch anything. That's what
All
she
right.
said.
With the okay, that's fine.
So we don't have to check on right. We just have to use the tuple x, y, remember?
Tuple x y.
Here, in the x plus 1.
Okay. Right.
And the, aha, I see what I see what the problem is. No, actually, no, x plus 1 is good and y is good. No problem there. We're always
Right.
checking x, y, and x plus 1, and y, etc. We're always checking the current one and the one next to it, right?
Right.
Okay.
Um.
So we have to replace the x plus 1 with what we got from the tuple, right? The tuple already
Right.
contains x plus 1. So it returns the tuple.x.
This one too, right?
Exactly.
And then this one would be. What's this thing? Return type is void. It's supposed to add it to the list and then return. So
Sorry?
just plug results for now.
Sure.
How would I do? passing already.
Yeah.
Nice.
You likey?
I like. I like. Yeah, much better.
Now we can easily check for the other items and just add a very simple algorithm here. Just return a new tuple to check.
Right. Well, like we did check the other ones. Like if you remember, we did it this way, and fortunately,
Oh, I forgot
our
about that. Cool.
yeah, unfortunately, the reason why it works is because we're checking diagonally. If you remember, where right here we're checking diagonally, and that worked for it.
Sure.
That made everything work. So
Let's remove
yeah.
all the comments from there and commit.
Okay. Let me. Uh,
You want to outline? What? Oh, okay.
so that
Actually, it might be better. Just say, oh, yeah, but you want to delegate and you return the new results. I mean, it might be better to actually even refactor that to a method instead. I'm not sure.
right now, I think it's pretty clear right here. So
Okay, but I will rename this to,
right here.
um,
Uh,
actually, no, not
detect.
that one. The check to like, check for each when we have a tuple. Oh, so the tuple is item next to current.
Uh, what
Um,
position next to current?
yeah, you know what? It should be like nobody knows what item 1 is. We can
So you
say
want to make
yes,
an
please.
object for it or something?
Like int x next
Oh, I see.
to me. The same with y. Place 2 and say y next to me or something like that. I'm not sure.
Okay.
And that way we would say, look at that. It's almost surrounded to the right. It's actually not surrounded to the right anymore. It's almost surrounded to some position, right?
Right.
Something like that. I'm not sure. Arg's rules is almost surrounded x next to me and y next to me. Cool.
Mm-hmm.
Um,
The interesting thing is we probably move is almost fully surrounded into this strategy, right? And the same thing with the fully surrounded by. Because if I look at this, where's all the find usages?
just Control V actually. These are the usages.
Yeah.
I thought you meant to go to the code.
Oh, I meant um, the usage. Like it's only used inside here.
Aha.
That's
Okay.
one. So like
Sure.
if I control B it and then I move, well,
Well, look at that.
it's actually
Scary.
yeah. uh,
I guess that's our next thing.
where is it? Where did I go?
You put it on the base class, maybe.
Oh, you want to put in a base class?
Maybe. Oh, actually, that's the only class that's using it, so don't.
Yeah. That's what I was thinking. Edge. Why can't I resolve edge?
That's part of board, I guess.
Uh, um, it's part of board, right?
Mm-hmm.
So
I think so. Well, if you go to the original implementation, you can see where edge is coming from.
Where was it? Oh, it's part of the rules. We made it part of rules. Okay.
So rules.edge.
So, well, it's gonna be args.rules.edge, right? Args. Oops.
And I think it's a const, so it shouldn't be a problem. Try rules.edge and see what happens.
Ah, okay. It's a.
Because it's const.
I see. Okay.
Oh dear. Actually, you know what? Hold on. Instead of doing all
Okay.
that work, just declare edge and use it and just before that line.
Oh, okay.
Like in int edge equals rules.edge or something.
Right. No, very nice.
And now we have the board.get stone color, and that needs to change as well.
Yeah.
So we have args.board.
Well, we can always do the same thing here. Board equals args. Do we have access to args? Oh,
Yeah, it's on the it's in the base class. We put it as a field. You should have it.
Okay.
It's underscore.
Well, it's like detect. You pass the value args, so it's not a property inside the class.
Okay. So you can move it to this method as an args. You can put it in the class.
Could you show me also like how would I do it? Control alt control? No.
What do you want to do?
You said you want to move it as a property of the class, right?
Control Shift R, introduce field.
Okay.
And now it's setting the field, and that's it.
Okay. Okay, so this would be args.board. Oh, I should probably move this
just as the first line, yeah.
Yeah. And then what's not running? Oh, because so then this one would be delete and delete. Nice. Same thing can be done with the fully surrounded one too. So since since we could have done this inside.
Well, remember to take small steps. Small steps.
Okay.
Don't change too many things at once. Make sure that you.
Is it Control P? Is it Control P or Control F?
What are you trying to do?
Do the same thing we did this.
Introduce field? Or
yeah.
inline?
Field.
Control Shift R will give you the menu you want.
Okay. Just copy.
Wouldn't that all this make the current class still a bit too big?
The current class?
Yeah.
You mean this class?
Yeah.
Never
mind. Fully surrounded. I mean, now this class and the partially surrounded class. Oh, actually, what you're saying is that look, this one only needs the fully surrounded. The other only needs the partially surrounded by, right?
Right. So I felt like that was with a single responsibility.
Nice. Cool.
It goes well.
I like it. Nice.
So.
What's interesting is that, well, first let's commit so that we don't lose this stuff.
Alright. It had a status. I thought I had to get ignore for that.
Do you want
wow.
to move the classes to different classes now?
Right
Or do you
now,
want to keep this all in the same file?
I think it's got big enough where we could move it to a different file.
Okay,
Yeah.
so let's do that.
Do that first.
Sure.
Okay. Is there an easy way
Oh, of
to
course there
move
is,
it
of
to?
course. Just F6.
Wait, say
Just put
F6?
F6 on the class name.
Oh, F6 on a class name. And then you wanted to probably move this to another folder, right?
No, 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 don't worry about it for now. Let's just F6 for the others as well.
6.
Yep. Okay.
Oops, wrong one.
It looks like a class, I agree.
Yeah. Okay.
What about the removable detector? Okay. Another one. Pretty sure we're not done yet.
I think.
Go back to board. Let's
Yeah.
see. Is that all we have now?
We got a stone. We have a stone remover.
Okay, do that as well. Cool. Nice. And the
So
removal
we got.
args. Removal args as well.
Okay.
Okay, now let's look at board.
So we got the class board, and we have the rules. Do we want to move rules?
Yeah.
Okay. So board should only have boards now.
Nice. Okay, and we didn't break anything, right?
Yep.
You want to run the test just to make sure?
Test.
Cool.
Yes.
So here's what I'm gonna do now. Oh, correct. That's not what I meant. Well, we'll talk about that later. What I wanted is to now we can look at this. We have the strategies, we have the board, so we can create a folder for like the new solution folder.
It's under add.
Oh, actually, it's in project. Yeah. Add. Hold on. Pausing for a second. Okay, so what I'm gonna do is I'm gonna move like a new folder. Let's rename it to like removals or something.
Removal detector, or do you want to just?
Yeah, we can go remove detectors as well.
I mean, I was just assuming that you're making a folder for the removal strategies.
Sure. So chain removal, fully surrounded, removal detector, removal arcs, stone remover.
All right.
What do you think?
I think removal doesn't have an E after it.
Oh yeah, sorry.
And then everything else looks good, yeah.
Okay, commit the thing.
Okay. Okay. What should I call it?
The big
Say
refactoring of 2012?
what? What you said?
The big refactor of 2012?
Sure.
Actually, we should call it basically removal strategies or something like that. Refactoring to removal strategies. Cool.
Cool.
Yep.
Okay.
Look at you zooming all the way.
Is it push origin master?
Just git push, I think, actually, will work as well.
Cool.
Okay. So, do you want to add another test for another feature, or do you want to finish for today?
I think we should finish for today. It's already 3 a.m. for me, so and I
Okay.
got work
Okay. It's
tomorrow.
only 3 a.m., dude. It's very early. Still have time. I'm just kidding. Actually, I would remove all those gray things over there at the top, like this one. I would
Oh
just,
yeah.
I would just continue cleaning. I mean, actually, my next things to do might be doing the what do we do?
Say again.
What I said is that my next new things would be to basically look at that fully surrounded and partially surrounded and see how we can make that nicer.
Okay.
But
Yeah.
we'll do that maybe next time.
Yeah.
Are you
I
happy
think
with
we
how the
still have
code?
a bit of refactoring to do
Sorry,
still. Cool.
are you happy with how the code is turning out now, or do you?
Yeah. I find it interesting. Like before, I was a little skeptical about it, but after refactoring, it's like a lot cleaner, a lot more confident about it. So
Cool,
yeah.
cool. Okay, so I'll see you maybe tomorrow. We'll see what happens. See you, everyone. Thanks for hanging out with us, and cheers.
Cheers.
We, bam. Okay, cool. That was nice. Now I'm feeling a bit productive.